Unit 3, Lesson 4, Hotspots and Volcanoes. Our learning target for today, I can explain why hotspots are not located at plate boundaries. I can compare and contrast different types of volcanoes. And then our success criteria. Student can describe how the island chain of Hawaii formed as a result of a mantle hotspot. The students can locate hotspots using page 5 of the Earth Science reference table. First thing we want to ask ourselves are, what are volcanoes? Most of us are familiar with them. We've seen them in movies. We've maybe never seen them in real life, but we know what they are and we know that they can cause a lot of destruction. So volcanoes are lava flows, and they are classified by their shape, their size, and their orientation. Lava forms at the surface, so this is what comes out of volcanoes, and then magma forms underground. This distinction will be important later when we start talking about different kinds of igneous rocks. So if we take a look at this map here, this is showing us major volcanoes around the world. So we have some kind of scattered over here throughout Europe and Africa, and then we have them really kind of concentrated along the west coast of South America and North America, and kind of all around the Pacific Ocean. So what I want to do is I want to look at this map and I want to compare it to a reference table page. Because when we talked about different types of plate boundaries in the last lesson, we talked about how volcanic islands form and how volcanic mountains form as a result of plate boundaries. So if we compare this image here to the previous one, I want to look for these convergent plate boundaries because this is where volcanoes are going to form at the surface. If I look along here, I'm going to notice that it kind of matches up with here. Now, in the last lesson, we also discussed divergent plate boundaries at mid-ocean ridges. Those also form volcanoes. However, because they're not at the surface, that's not going to be part of what we're discussing today. So the conclusion we can draw from comparing these maps is that volcanoes at the surface occur along plate boundaries, specifically convergent boundaries. So here I have highlighted all of the convergent boundaries, and this really matches up well with that map of major volcanoes around the world. Now, depending on the type of plate, whether it's oceanic or continental, will determine the type of volcano. So some of them are volcanic islands, okay, like out here in the Pacific. And then we also have volcanic mountains. North America, you have Mount St. Helens. And then you have the Andes Mountains, which have multiple volcanoes in them as well. Some volcanoes exist in the middle of plates in areas that are called hotspots. So here in this middle spot, we have the Hawaii hotspot, we have the Yellowstone hotspot. So I just want to point those out, and those were in our previous map as well, and we're going to discuss how those form later on. So now let's talk about hotspots. So here we have highlighted the Hawaii hotspot and the Yellowstone hotspot. Both of those are part of the United States, although they are located on different plates. These are typically found in the middle of plates, so away from plate boundaries. It could be in the middle of a continental plate like Yellowstone. So here's Yellowstone. Or it can be in the middle of an oceanic plate like Hawaii is. So Hawaii is an island. Yellowstone is a very large hotspot that is located on land. It does not have an active volcano, but there is active things happening coming from the mantle. So what these are stationary hot areas that the plates move over. So the hotspot is actually a single point in the mantle, and the plates, as we know they move, the plates move over that hot area, creating sometimes island chains. So here shows an image of what we call a mantle plume. So this is a hot area in the mantle that is melting the rocks, and so as we melt things, we know that they are going to rise because they're going to become less dense, and as that material melts, it comes to the surface, forming a volcano. So here we can see all the different islands of Hawaii, and some of these are more active than others. Some of them are completely extinct, and that's because a plate is very slowly moving over that hotspot. So the area that's directly over the hotspot, which is where Hawaii is currently continuing to grow, whereas some of the islands that are farther away, Kauai, Oahu, are older islands and they are not as active or active at all. So I'm just going to show you a little bit of an embedded video here that kind of shows how the Mantle hotspot works. Okay, so you can see at the top here the plate is moving, but the hotspot is remaining stationary. So I'm going to play this one more time. So take a look at the hotspot. Notice that the hotspot remains stationary and there are volcanoes or land forming above it while the plate is moving on top of that hotspot. So here is an image of the different Hawaiian islands from space. So you can see here, this is the island Hawaii. This is the youngest island that is most active. And then as you go in the north, kind of west or west, these islands are younger and not as active because they are not directly over the hotspot. And then to the east of Hawaii, you have underwater volcanoes that are building up slowly, and eventually this will turn into new islands as well. So these smaller islands where the extinct volcanoes are have sort of eroded over time, the rocks wear down, and so the islands are becoming smaller, whereas the active volcanoes are continuing to grow, so there's more land forming in Hawaii all the time. So moving on to the types of volcanoes. We have cinder cone, we have composite, and we have shield volcanoes. And in the beginning of the lesson, we said that volcanoes were characterized or classified by their shape, size, and orientation. So you can kind of see the shape and size here is different just looking at these images. And they are very distinct in the way that they form, and a lot of that has to do with the composition of the lava inside of the volcanoes. So we're going to start with cinder cone volcanoes. These are formed when ash and cinder are violently spewed out from an erupting volcano and blown to great heights. These are composed mostly of cinder and ash. So these don't have a large amount of lava flow. These are typically ash and cinder. They have very steep sides and a small crater, so they're kind of like little mountains. And they have a single vent. So the lava and the other things coming out of this volcano are only coming out of one location right at the top. And these are often found with other types of volcanoes. So you can find different kinds of volcanoes in different areas. Hawaii is mostly made of shield volcanoes. Hawaii is located over a hot spot, but there are cinder cone volcanoes also located in Hawaii. So this is an example of a cinder cone volcano that was erupting in Mexico. It was started erupting in 1943. It grew out of a cornfield. So it erupted for 9 years, growing to 424 meters and burying nearby towns in ash. So I just want you to understand it started as nothing and then over 9 years erupted, creating a 424 meter volcanic mountain. So the next type of volcano we have is a composite volcano. This is formed by alternating levels of lava, ash, and cinder. The eruptions are very violent because of the buildup of pressure, so these are actually more violent than the previous volcanoes. And lava escapes from many side vents. So unlike the cinder cone volcano, which only escapes from the top, we have lava flows on these side vents, which are things that kind of go over to the sides. And these typically are much larger than cinder cones. So cinder cones are going to be the smallest. They're very steep on either side, but they're not very large. An example of this kind of volcano is Mount St Helens. This is located in Washington State. The last time it erupted was in 1980, and it was a very large eruption. You can see here, this is some of the ash plume that was coming out of the volcano. There was a 5.1 magnitude earthquake, which is a very large earthquake that caused a massive landslide, and half of the mountain collapsed, or a side of the mountain collapsed. These cause large-scale pyroclastic flows, so not necessarily lava flows, but flows of very hot ash and cinder. And this volcanic eruption killed 57 people and caused $1 billion in damage in the United States. So here you can see what it looked like before it erupted. And then there was this very large landslide that occurred as a result of the earthquake. So this whole side kind of caved in. And then this is what it looks like today. And scientists are constantly monitoring this volcano because it is technically still active, although it is not actively erupting. And the last type of volcano is a shield volcano. So these form when eruptions produce runny lava that flows across a vast area instead of making a cone. So these are kind of like those classic lava flows that you imagine when you think of a volcano. They generally have many side vents, so many places for lava to kind of flow through. And an example of this is Kilauea on Hawaii. So this is what I kind of think of when I think of a volcano. It's not slow, but it's not super fast moving lava when it erupts. It kind of just flows across everything in the land and burns everything. And then the last thing here is a caldera. So a caldera forms when there's a collapse of land following a volcanic eruption. Sometimes this is confused with volcanic crater, but this has to happen after an eruption, not just the crater of a volcano. So this is an example of a caldera. And Crater Lake in Oregon is an example of a caldera in the United States. It formed from the collapse of the giant volcano Mount Mazama. And in the center of the lake is a small cinder cone. So this is the small cinder cone. I believe it's called Wizard Island. Sorry. And then this is me when I went to visit Crater Lake in Oregon when I used to live out there. Okay, so that's the end of this lesson. Our learning target was I can explain why hotspots are not located at plate boundaries. I can compare and contrast different types of volcanoes. Our success criteria. Student can describe how the island chain of Hawaii formed as a result of a mantle hotspot. And students can locate hotspots using page 5 of the Earth Science Reference Table.